Okay, so for today's lesson, I'm going to talk about the applications of law of sines. So the examples I'm going to talk about are coming from your handout. It's example number 37 and 38. And then in the next video, we're going to talk about a different example, which is a SSA situation. Okay, so for this example, question number 37 says, CoStar Station Able is located 150 miles south of Station Baker. So drawing it up, we have Station Able is right here, and Station Baker is up here, and they are 150 miles apart. So 150 miles apart. Okay, so the next thing it says, a ship at sea sends an SOS call that is received by each station. The call is to the Station Able. It indicates that the ship is north 55 degrees east. So that means it's going to be on the east side. So that's going to be on the east side. So in that case, it's going to be over here somewhere. And it says north 55 degrees east. So that means this angle here is going to be 55 degrees. And the next part says the call to the Station Baker indicates the ship is south 60 degrees east. That means this angle here is going to be 60 degrees. Now the question says, how far is the station from the ship? Each of those stations. For A, and part B says if the helicopter capable of flying 200 miles per hour is dispatched from the nearest station, how long will it take for it to reach the ship? So that means we have finished the diagrams. In that case, we can go ahead and write the relationship. In this case, let's call this angle A. In that case, sine of A, which is on this side, is equal to sine of A here is going to be 55. So sine of 55 divided by A is equal to sine of B, which is 60 degrees over B, is equal to sine of C over 150. Okay, so from here you can figure that this is a angle side angle case, angle side angle situation. So that means we only have one triangle for this question. So in that case, first step number one is to figure out what C is. C is equal to 180 degrees minus 55 degrees minus 60 degrees. This gives us 65 degrees. That means we know what C is. C is 65 degrees. Now, all we have to do now is figure out A and B are. So in that case, we can use sine of C over 150, okay, multiplied by is equal to sine of 55 over A. So in that case, sine of 65 degrees divided by 150 is equal to sine of 55 degrees, make sure you put degrees, divided by A. That means A is equal to sine of 150, sine of 55 degrees divided by sine of 65 degrees. Okay, and the other one is looking for B, in this case sine of 65 degrees divided by 150 is equal to sine of 60 degrees divided by B, which implies B is equal to 150 sine of 60 degrees divided by sine of 65 degrees. Okay, so if you put it in your calculator, the answer you get from this is, let's see, 135.57375 miles for A, and B is equal to 143.333 miles. Okay, so in that case, we have my A and my B. So in this case, A is equal to 135.575. Okay, this is in miles, and this one's going to be 143.333 miles. Okay, so the question here is asking for A, how far is each station from the ship? In this case, from Baker, it's 135.575 miles, and from Able, it is 143.333 miles. Okay, now part B here, in that case, we found A. So in that case, everything here is A. From Baker and Able, it is, from Baker, it's 135.575 miles. And then for B, because that's the distance, 143.333 miles. Make sure you don't get these things confused, okay? Now for part B, the question says, if the helicopter is capable of flying 200 miles per hour, how long does it take for it to reach the ship? Okay, they want it in, they didn't specify. In that case, which one's closer? It's closer from Baker, right? So it's going to be 135.575 miles divided by 200 miles per hour. So if you do the division, you end up with something like 0.678 hours. Because when you flip this hours, it goes to the numerator, you end up with 0.678. And if you put that in your calculator, this comes out as around 40.673 minutes. Okay? So in that case, it takes around 40 minutes to reach the ship. Okay? So that's example number 37. Okay? Now, let's look at the next question here. The next question says, distance from the moon. At the same exact time, Tom and Alice measured the angle of elevation to the moon while standing exactly 300 kilometers apart. The angle of elevation to the moon for Tom is 49.8974 degrees, and the angle of elevation to the moon for Alice is 49.9312 degrees. See the figure on the right. So in that case, I've already drew it up over here. Now the question says, to the nearest 10,000 kilometers, how far was the moon from Earth when the measurements was attained? Okay. Okay. So looking at this here, you might be like, how the heck do we do this? Now, so one thing you should have to remember is, technically, this is still an ASA question. Okay, it's an ASA. Okay, it's probably best practice that you write down what type of triangle you'd be dealing with. Okay, so for this one, they give you a hint over here. That means the complementary angle here, the supplementary angle here, comes out as 180 minus 49.912. So putting in a calculator, 180 minus this number gives me 130.0688. Okay, that's the angle over here. Okay, make sure you put angle signs. Now, so that means we have to also find what this is. Okay, so based off this diagram, you have angle, side, angle. So it's an angle, side, angle triangle. Now, putting in a calculator here, this angle here is going to be 180 minus A minus B. Let's call this A and minus A, B. This comes out as 0.0338. Okay, degrees. Now, so let's put this into a calculator. Put this into ratio first. So sine of, in this case, 49.8974 degrees divided by A is equal to sine of 49.9312 degrees divided by B, which is equal to sine of, in this case, we already found what C is. C is equal to 0.0338 degrees divided by 300 kilometers. Okay, so now we have this relationships that we can have already set up. Now what we need to do next is solve for what A and B is. Okay, so in that case, what sine of A, so in that case, use this one to refer to this. So in that case, sine of 0.0338 degrees divided by 300 is equal to sine of 49.8974 degrees divided by A. That implies by rearranging, A comes up, 300 goes up, and sine of 0.0338 comes down. So A is equal to sine 300 sine of 49.8974 degrees divided by sine of 0.0338. Okay, so this number comes out as, in this case, we get, make sure I have the right one, we get 388,980.140 miles. Okay, now for B, situation B, we have this one, sine of 49.9312 degrees divided by B is equal to sine of 0.0338 degrees divided by 300. That means B, by rearranging, B comes up, this comes up, and sine of this one comes down. So in that case, B is equal to 300 sine of 49.9312 degrees divided by sine of 0.338 degrees. So you put in your calculator, gives you 389,173.319. In this case, it is in kilometers. Okay, make sure you have the right units. Okay. Now the question here reads, to the nearest 1,000 kilometers. So to the nearest 1,000 kilometers, we have So this one comes out as approximately 39,000 kilometers. So in that case, so the answer here is around 39,000 kilometers. Okay? Same thing with this. This is approximately 39,000 kilometers. Okay, so it's approximately. So my answer to this question is around 390,000 kilometers. So Tom and Alice, they are around 39,000 kilometers away from the moon. Okay, so over here for this question, we have a diagram given to us with some of the parts we have to fill out, and for number 37, it's completely done from scratch. So in that case, you should be able to do these from scratch as well. So in that case, first thing, number 1, determine what type of triangle we'll be dealing with. Well, that happens after you've drawn the diagram. So draw the diagram first, state the relationship, and then state the ASA or SSA. Okay, so for these two examples is angle, side angle, and make sure you answer the question. Okay, so those are the two examples, and I'll see you in the next video. The next video we'll be talking about the side angle example. Okay, so see you in the next video.